ready? Okay, well, I'm going to talk about soldering for a while. I was a musical instrument repairman for, well, I have been since about 1983. And in some ways, that's kind of how I ended up getting into rod making. And from the time I started making rods, and I think I'm on my 84th right now, I have made every part of them. I've never bought parts, and it's been something that was really fun for me. Is because, like Alan was talking about last night, it's fun to make every part of the rod. I guess I should stand up. It just was something that was kind of fun to me, but I realized that in doing it, instrument repair and building your own parts are not all that different. And there are some things here. First of all, how many of you have ever soldered? Has anybody soldered? Okay, how many of you have ever done it well? There's a difference. There are some. I'm going to show a few things. Gary wanted me to bring a trumpet. You can see, first of all, several things that I do. You can see some of the messes people make. This is a trumpet that somebody tore the bell off of. But how I learned to do it, instruments, especially brass instruments, are held together by solder. And so I'm going to pass this around. You can kind of see what's there. Be careful, there's some sharp edges, things on there. But that's what holds it together. And one of the things that I like the most is that it's lead solder. I mean, do you all, when you're soldering your parts, do you use silver solder or are you lead soldering? Anyone? Lead. Okay. Silver soldering, I use very, very, very little. I use it on one thing and one thing only. I solder my little hook keeper rings. That's all I do it for, because lead solder is easier to control. You don't need as much heat. It flows better for me, and you don't really need the strength that you get from silver solder. Silver solder for me, I learned to do it when I was fixing like clarinet keys. People would break a nickel silver clarinet key. And so you can take it, you can put it back together, you can glob on a bunch of silver solder around it, because it doesn't flow well for me. Not enough to do what I do, and then you file it down. You can almost make it where you can't even see that it ever happened. It's really, really strong, but for crying out loud, I've never had a ferrule fail, and you're holding them together, and I don't want to have to get that much heat on a piece of brass, because one of the things you do when you've got a bad dent on a trumpet, you heat it until it's red hot because it gets really soft. And I don't like to heat the parts that I'm making, and I really kind of want them to stay hard and sturdy. I don't want to reheat them to red hot to have to use silver solder. So what I'm using is a type of solder that, well, unfortunately, you can only get at instrument repair warehouses, and I'll talk about that in a minute. It is a 70-30 blend. You can look all over the internet, and you can get 60-40, and it's solid core solder. Don't get acid core or flux core. It's a pain in the neck. But the 70-30, 70-10, 30 lead is really, really strong, and it flows and melts real easily. If anyone is interested in getting some of this, I can order it. I have an account because I'm an instrument repairman, and I'd be glad to sell it by the foot or whatever. I'll sell it for what I got in it if you pay the shipping. So if anybody wants it, talk to me. It's really good stuff. I mean, I have used 60-40, but it's not quite as hard. It doesn't hold as good. It's all right. So I'm going to try to demonstrate.
What about the 90-10s and the lead-free solders?
I'm going to talk about that too. Okay. I'm going to get there. The things I'm going to solder right now, and I'll show you as I get into this because I've got all three of the things here. I'm going to start off in rod making and in repair as well. I have 4 or 5 different processes in my like I make, reel seat caps. I make them lots of different ways. I don't know if you can all see this. I start with some of Allen's tubing. Have you all seen my reel seats and with the step down button? So what I'm doing is I'm making a nickel silver plug, and I leave about, I don't know, I hope you can see it. That is the plug. That is solid. This will get soldered into there, and then I put it on the lathe and step it down. So that's one of the things that I want to show because it's probably the easiest thing to do. One of the things that I see when people solder the most, they don't use the correct flux, and flux is your friend. That's what I have. 2 different things. Cleanliness. You've got to have things clean. If you have any dirt, any oil, that solder will ball up and fall off. It won't flow. It won't go where you want it. You got to use solder or solder flux, and don't use paste. Don't use paste flux. Once you start using liquid flux, and I'm going to, I'll start passing this around. You can get this at Ace Hardware, which is another good thing if you want to take a look at it. And everything I'll say about this is everything having to do with solder is dangerous. You've got lead, you've got acid in the flux, you've got cadmium in the silver solder, so ventilate. and wash your hands. Don't eat something right after you do this. So, and you've got fire. Hey, let's catch everybody on fire. What could possibly go wrong?
How about a
Oh,
salt?
and don't touch things when they're hot. Don't ask me how I know.
Whatever you do before you start, don't say, watch this.
Right. So anyway, clean and flux is your friend. That's what I tell everybody. Don't be afraid to overflux. Flux is made up of, I believe, glycerin mostly and acid. The acid cleans whatever's not in there, tends to, if there's a little bit of residual oil or dirt, it'll kind of clean it, and the glycerin helps it to flow. So you really, really want to have everything as clean as you possibly can. One of the things that I'll do, and when you get this tubing, is Alan here? I don't know. When you get this tubing, almost invariably, it has got green goobers in it, and it has machining oil. It has everything in it. If you take it just like this, it's not going to flow. So I start off by doing several different things. You can go to Harbor Freight and buy these by the boxes. I start off, these are wire brushes. Harbor Freight can be good for a few things. These are really very good, and they solve two different purposes. If you've got oxidation inside, which this one's fairly clean, surprisingly, it has a little bit in there. I'm going to solder it on this end. What I've done, I've already put it on the lathe, and I've faced this off so that it's tight, so that I can get this plug in there. You want to start off with just a brush, and I get it in there, and I like it because they have this, and you can twist it easy. It doesn't hurt your hand. And I will get that thing and just scrape it out. I don't have the sink, but with soap and water, I'll actually get, the next thing I would do is get one of my, and they also come with plastic brushes. And I will load that up with lava soap, and I will scrub the bejeebers out of this thing. And then run hot water through it. And like I said, I'm being really, really clean with all these things. And so I've done some of that. Denatured alcohol. No acetone, denatured alcohol. Q-tips, rags, all those things. Have them ready. But I'm going to take a little bit of the denatured alcohol. Let's see if there's some. I may have cleaned this one really well already. But you want to, yeah, I did. I cleaned this before I came out. I forgot. You want to just clean every surface of that as you can until it comes out. See, that has a little bit of black on it. You don't want any black on there if you can help it at all. One other thing. With those wire brushes, one of the things I really like about the wire brush is that it scratches up the inside a little bit. And a bright surface solders way better. Invariably, people would try to solder, like get a trumpet like this. It would come in and it was broken, and they would just try to clamp it back together just like it was and use old solder. It doesn't work. What's that? Oh, I thought I had a question. Okay, so you get it cleaned out with the alcohol.
Randy, is a light physical tooth when you're going to solder is probably a good thing.
What's that?
When you scratch it up.
Oh, yes.
You want that little bit of physical tooth.
You do. You just want a little bit. It just makes it flow better. Now I'm going to clean off the inside of this because anything you can do, this is probably pretty clean because it was done on the lathe and it's just bare metal, but I'm always really careful about that. Okay, so I'm going to put this together because I want to be able to solder this in. This is probably the easiest thing that I soldered because you can solder it from the outside. Before I start, again, you're seeing that silver solder or the flux going around. If you're going to solder, first of all, you don't want this stuff to tip over because it's acid-based and you don't want it all over the place and you don't really want to touch it. It's a light acid, but you still don't want to get it in your eyes, you don't want to get it on your clothes, and you don't want to spill it. But the thing that's going to help the most, and I buy little glass bottles if you can, and get a glass eyedropper because you can very easily control where you put your drops of flux. If not, it just goes everywhere. And since the glycerin in flux helps the solder to flow, if you get junk all over and the flux flows all over the place, the solder will follow it. And now you're trying to clean it off, and cleaning off solder is a pain in the neck. And especially if you're trying to solder something that's knurled, then it fills your knurls. Well, you pull it off and throw it away and do another one. Because it won't blue. Especially if you blue. Lead solder doesn't blue well. So you really want to be careful with how you put this on. Most of this is in my little write-up in here, but anyway, this will give you some ideas. So what I'm going to do first, I will flux it, and I will actually put a drop. I hope you can see this at all. Around the outside. Good, I got some Q-tip stuff. Get out of there. That's all right.
Randy,
Yes.
breathe. Calm down.
Oh, I am. No, I'm talking. Okay, so there it goes. All right, get that on there.
How tight of a fit do you have on that?
Quite tight. I have it quite tight. So I got just a little bit inside there. It's tight enough that I am going to have to give it a tap. So I keep it pretty tight because I don't like it to come out. Okay. Next thing I'm talking about with soldering, you want to have whatever you're soldering to be really, really secure. First of all, it's got acid on it. The other thing is it's really hot. And you don't want to touch it, and you don't want it to fall on your feet. I have a foam floor in my shop because it's great on your legs and your back and stuff, but yet there's lots of little burn holes from stuff falling. They're barrel shaped, I don't get it. Okay, next thing, with the lead solder. If you take it just as it is in the round, it's like 1/16 of an inch or whatever. When you heat, it really wants to just take that glob and put a big glob on there. So the first thing I do is I take it, hammer, and on the same vise you're using, and hammer it flat. You only need about an inch or so out of there. It's nice to have them in a spool like this if you can or whatever, so because you want to solder from a little ways away. Okay? So I've got this. Oh, let's talk about torches. I'm getting ahead of myself. I used to, in doing instrument repair, I had a acetylene, not oxyacetylene, but an acetylene torch setup. And I kind of got away from that only because the cylinders are this big, and it takes up a lot of shop space. They're expensive as can be, and they're real hot. You can let things get away from you really quickly. They have lots of different torch setups and tip setups. It's great. But if you have to go fill it, you put a dent in your pocketbook.
You had a classical jeweler's torch.
Absolutely. So for lead soldering, I am using just strict propane. These little torch tips, things like this, you can get them at Home Depot, and it's a self-lighting, and it'll work twice. They really are. They're cruddy, but so that's why I have cigarette lighters, and that works fine. But these work really, really well. I'll get into this one later. I use that as a MAP gas, and I use that for silver soldering. But this is for lead solder, so you can just barely get it lit. I'm going to talk about the flame. I don't know if all of you can see the flame. If you can see it really closely, it's two different colors. The outer side is pretty light. It's a very light blue, and it's a light blue color, but it's darker. The hottest part of that flame is right at the tip where it changes color. That's what you want to paint with the flame. You want to paint that. So what I'm going to do to start. Yes, somebody break the wind. This is the problem.
Nobody break the wind.
All right.
What are you talking about?
Please don't.
Especially with the flame around.
Yep, don't. All right. When you start to solder, I already fluxed this. You want to keep your heat moving. Don't just heat it from one side. And actually, when you vise it up, keep it a little ways away from this vise. This is a nice big piece of iron.
So it's a huge heat sink.
It is. It's a heat sink. Does everybody know what a heat sink is? It absorbs the heat. Takes that way longer to heat up, and it's not as efficient. So when you start to heat, keep your flame moving. And what I'm trying to get to happen, and on this when it's this tight, you probably won't see it, but I heat it up almost enough to get the solder inside the bubble. On here you won't see it as much. Then I will flux again. And this time, and if it bubbles, you know you were hot enough. When you put it on there, did you guys that were closer, could you see it bubble?
No.
Okay, it bubbles a little and you'll know it was about hot enough. Now, I'm going to go back and I'm going to heat this whole big plug. I'm going to heat it again. I'm going to come over to this side. I'm sorry, folks. I need to see over here. Going to heat it? Well, no, I'm not. I'm going to block the wind. Anyway, the reason... Did you turn it off?
No, I didn't turn it.
I hope not. That's why I have another.
Yeah.
No.
Time to change it.
No, it's got it in here.
Maybe because it was laying down.
Might be. Yeah, but I don't want it to tip.
I'll hold
That's
it.
why I have an extra cylinder, I hope. If not, I'll use MAP gas. Of course, you're going to be a pain in my butt, aren't you? Okay. Yep, I figured that would happen. That's why I brought another one. This has got
Careful
gas
that.
in it. Yeah. I got you.
Worried about me heckling you.
No, I'm heckling myself. Yeah, there was gas.
I told you not to break wind.
Yeah. Nice smell, though, isn't it? Hopefully I have some. If not, I'm going to use just MAP gas. Yeah, I will. Where did my lighter go? No, I've got a problem in the tube. I bet something happened on the drive up here. Okay. We'll go on with this. These are great, too.
spicy stuff.
Okay, I don't like these because they're unwieldy. MAP gas, I was going to get to this later. MAP gas burns much, much, much hotter. That's why I like it for silver soldering. Okay, we'll start over again. Anyway, all right, going to heat it. Now, I try to touch it since I flattened it, hopefully it'll go on a lot faster. You keep touching. If it's hot enough, it'll go. There it goes. And because it was fluxed, I wish you guys could see that closer. I put one drop and it went zip the entire way around.
You can't, your ankles.
Yep, what I'm going to do, okay, buy yourself a squirt bottle of water because that'll save you. It's hot. It'll save you. Not sure how hot this is yet. It's not bad. I want to pass it around, but I don't want you. And remember, there's lead on the outside, so don't touch the joint unless you're going to go wash your hands, Jeff. Yeah. Okay. You can. And when this comes back, I'll show you how to clean up. But you can see how this. It was one little drop. Okay. So that's the easiest one to solder because you're soldering from the outside. Ferrules. There's all kinds of things that have to happen on ferrules. And they can be a real pain in the neck. I'm hoping that this isn't going to be, that's really hot. All right, for ferrules. The biggest problem I had with ferrules was figuring out a way to hold them. And just getting them so you could keep them where you could heat it up and you wouldn't stick them in a vise. Vices like this, they hold it, but they're a heat sink, and they also have serrated jaws. They're a pain in the neck. So I came up with a little clamp like this, and I use this for just about everything I do. I have a big hole on this side. It holds my butt caps when I'm going to solder the knurl on it. And aluminum, this is a block of aluminum, it's not a real good heat sink. It heats up quick and it doesn't draw it out. So it works really, really well. I have designated holes for each different size ferrule. You can set them down inside there. So what I'm going to do first, I think, I want to, let's see, I'm starting to go towards step-down ferrules. I like step-down ferrules. Larry, you were talking about this yesterday. You don't like soldering plugs.
No. Water stops kind of pain in the butt.
Yeah. Well, I've got several different things I'm going to do here. Okay, so on step-down ferrules, they start off with two different size tubing. You have the outside shoulder. Let's see if I can get this one apart. Yeah, and you have the internal one. I have these measured, and I know how far they go in. Okay, that's how far they've gone in. That one does the same thing. I actually think this one had to be shouldered. What I'm going to do, I'm going to put this up in the vise. Let's see, which one is it? I got to remember. They're tight enough going in there. It holds it really well. It doesn't fall out. It's just, and it doesn't scar it. So you can pop them in there like that. This holds really well in the vise. By being able to turn this, you can lock it in place. This makes this a whole lot easier. I don't want to solder this from the inside because I don't want blobs of lead to get in the way of me trying to set this ferrule on the rod. I really want just a tiny touch. So what I'm going to do exactly like I just did with that one. And I'm going to start out, again, by cleaning it. Now see if I can get, if this one's dirty at all, but it's been machined, so it's probably clean, but I always am careful. I just want to say. Q-tips are also great. I like them. You do if you pull some cotton off.
Or
You have to pull a little bit off.
Go to the beauty supply place. They have those pointy ones.
Yep.
They are a little smaller.
Ooh. Anyway, you can see the junk that's coming off of
what you
there.
guys have, but ours is Home Sally's beauty supply.
There you go.
I send my wife. Hey, pick me up some chips.
The other thing, when you use alcohol in here, dry it out. It's flammable. You just don't want it in there. Clean both sides. So that, let's see, all right, that's going in this way. Cleaning it out. Now I'm going to fit them together, just barely. Flux. Remember, flux is your friend. Always put a little drop on the outside. Twist it around. I'm getting flux all over me. Okay.
So why wouldn't you, Randy? Why wouldn't you use a paste there?
You
It'd stick in there. It'd stay in better.
No, this is really tight. You don't need it, and the thing is, you have to heat it and have it melt, and you're putting it on with something else, and it's just messier. You don't have the control that you have with liquid flux and an eyedropper. An eyedropper with one little drop, you can put it exactly where you want. Paste on the inside, sure, you could do it. On the outside, not so much. And if you're at a weird angle, you can get that in there so much easier. I like liquid flux really, really a lot.
So how do you know, different question, I'm sorry.
Sure.
How far to actually input the internal?
Half. What I try to do, and I've tried to find other people what they think you should do on it,
No, but I mean, you just went like this.
because I have it shouldered off.
You did have.
Yeah, I have it measured, and I know exactly how far it's got to go. I want to make sure
Down the slide,
it has, because right,
side,
on
shoulder would
the male side, the slide side. Yeah, and so it goes in exactly as far as you wanted it to. I'll pass this one around. I want to make sure I am in exactly the right place. Yeah, I want to make sure I didn't change this. No, that one's not quite far enough. This one, unfortunately, the tubing is just a little bit different size, so that one didn't need to be shouldered. That's the problem. I'm going to do it one more time, and then I'm going to pass this around. Let's see, did I get it? I'll probably undo this one at some point, too.
Do you already
Okay, that
have
works.
the moisture cap in the bottom of the male slide?
Not yet. I'll do that in a minute. I have that ready to go, too.
So you'll
Oh, the moisture
solder your
on the
slide.
male slide.
Yeah, I'll just pass it around. See, here's the second tip. You want to see? You see him. Pass them around. That'll answer that. Okay, so I've got my first little drop of solder in there. I wonder if that would work again. Probably not.
What?
No.
Flux. Drop of flux.
I will. I already put flux.
No, you said you had a drop of solder. You have a drop of flux in there.
Oh, right, I have a drop of flux. I get talking and I forget what I'm saying.
You
Okay.
already got your seriations cut.
Yeah, I did.
You'll do that afterwards.
Nah, I do it first. If it starts to belt, and I'm having to do this a little different because it gets hot fast. Okay. And I like to be able to keep keep the solder a little ways away so I don't get burned. I like to straighten it out because you can control it and you can move it with your fingers. There it went. Nope, it's too hot. And once it gets too hot, you are in trouble. See, this is why I don't use nap gas for soldering if I can help it. A good way to cool it, though, is with liquid flux. It's a good coolant. And it's readily available through Ace Hardware. Is the only place I can find it. There it goes. Okay, now we're hot enough. Now, lead no matter what you do, you're going to get it off. You're going to get lead on the outside. So, before it cools, you can either use Q-tips, but they burn a little better. Get painter's rags. Be careful, don't do that. Especially if you've got alcohol on it.
You got a piece of scotch tape.
I use that for cleanup. This is to get off drops of lead. Scotch Brite won't get off drops of lead. Every time you touch it, it'll flow, but you always end up with a bump of lead that you don't want. Lead is an interesting thing. Okay, don't let me get talking or I'll burn myself here. Lead will leave a stain. No matter what you do, you can see it on there. Even when you wipe it off, it will leave a stain. So you're going to need to clean it up. And there's lots of ways you can do that. But what I have found the most, and I couldn't bring that with me, I use what's called, I call it a bench motor. And basically it's a quarter horse, 1725 RPM electric motor with a foot switch. And it also has a Jacob chuck drill chuck on it. So what that does for you, and this has got just a little, I'm going to do it one more time. It allows you to use your foot. I chuck these things up in there and use a little steel wool. So you don't want to change that too much or you'll mess up the way the slide goes in it. But you can, let's see, where'd I go? And that'll take off the stain. Heat will not take off that stain. There it goes. Okay. Now, this is where I'm going to do this. Now I'm going to solder in the plug that you're talking about. And this is where I do it a little differently. Now, because it's clean, I hope it is, I'm not going to assume that it is. I'm going to do it again. I'm going to reach down inside because, I don't know if it's solder flux leaves a residue, but if it's not clean inside there, you're in trouble. So I'm going to do it one more time. Yeah, see, it all of a sudden got a lot darker. You start getting black out of there, no, it's not good. And you not only want to clean where you're going to solder, clean above it, because the solder flux flows and it brings dirt. If you haven't got it cleaned up around it, it's just going to bring whatever's nasty in there and bring it right back down into the tube. I don't know, you can see it's on there. I'm going to pull a dry one in there to get the alcohol out. And sometimes I like it to be a little bit more compressed, because it really gets the stuff out of there better. Gives you a nice tight seal. Okay. Okay. Now, I use brass most of the time, unless I have nickel silver, because brass is more readily available, and it is cheap. And nickel silver is a little more expensive, and if all I'm going to do is use it for the end of the thing, which you're not going to see anyway, why? And so I generally try to use
Do you think you're
brass.
a reincarnation of Landman or what?
Oh, I don't know. Sure. That's not a bad thing, is it?
No, it's not.
Pretty much, I turn my little end plugs, because every piece of tubing is a little bit different.
That was actually a compliment, Randy, because of all the old hardware I've looked at, Landman's from the late 1800s, early 1900s
Yeah.
are some of the sweetest, finest fitting barrels in this day.
Really? That's cool.
I mean, they are impeccable.
Cool.
So
I'm using liquid
you're
again.
using bar stock that you've turned down and cut off.
No. Oh yeah. Bar stock brass for an end plug.
The rod stock.
So what I'm doing now, I'm just getting just a little drop of flux inside there, holding it right. I make my plugs quite tight, and I make them just a little bit long. I make them tight enough that literally I tap them in until they're flush. Once they're flush, what's that? Whatever looks good. I don't really, that one's one I'm not going to get hung up on.
What about the extra weight?
Only on a 3-piece.
I'll make you a set, and I'll actually fill it all the way. Okay, this is one place where I use a little, I don't know, you guys have all probably done this too, a little different trick. I'm going to tip this over so that it holds tight. This vise is being kind of a pain. Anyway, get that in there tight. I got scissors. Another place where when you have hammered your solder flat, on something like this, what I'll do, I don't know if I can show you, I'm going to take just a pair of scissors, it's soft, and I am going to cut off, like whatever it flattens to, basically cut off, it's got to be small enough to drop into that hole. So I'll cut off one little tiny piece of solder, and I will drop it down into the hole. I don't have my lights. Yep, it's in the bottom.
Do the light?
No, I got it. I could see. Thanks, though. I'm going to drop one more drop of solder down inside there. One more flux. God, would you... I can't... You know what I mean. Oh, sorry.
We know, but they don't.
Okay. Yeah, I don't know what I'm talking about. Yeah. Okay, I'm going to put it in upside down if I can. Or, excuse me, not upside down. I'm going to put it in this way. But I'm going to tip it. I put it in backwards, of course. It holds it tight enough that I'm actually even going to move it down that far. That plug's in there. I dropped a piece of solder down into there, and I put flux in there. Most likely that was enough. I'm going to cool it and see. If you get them tight enough, they're really nice. They stay in there themselves. If they're falling out, it's a pain in the neck. If you turn them the way I do, and they happen to be a little bit small, bring it over here, take a hammer, and hit it, peen it, just on one side. It expands it just a little bit, holds in there just nice. Lots of little tricks. Let me see if I got it.
Do the light?
No. Okay, I'm gonna, again, this has garbage. This has,
I lost without this.
you can see it. You can see it, it's in there and it flowed. That's all there is to soldering on a male slide. There you go. Okay, I'm going to move on. Then this is also the female side now. And this is something, Larry, you were talking about yesterday where you have a pain. I think this is what you meant, right?
Yeah.
Soldering this in. Okay. Let's see, I need my junky calipers with me. Again, this has actually been a really great thing. I made a little device that will sit up in the top of this. I'm going to see, let's see, which side do I want? Yeah, thanks. It goes in there, I think. Do I have it? Yeah, it drops all the way in. I got to get that. It's got to come up just a bit, just a tiny bit. This will hold this in place. The vise is not one to hold me very well. It's an old vise. This is my grandfather's from the turn of the century. No, and I use it for actually vicing nodes. I have 2 vices set up. I like that. Okay, so I've made this with 2 different little... The hole is big enough to have this go in and out, but then these will drop in the hole. So I made little inserts that makes it so it's not going to fall down. The slide length. Let's see, where did I go with the slide length? I need to know what it is. Did I hand out both? Yeah, I did, didn't I? I need to find that other mail. What did I do with it? Let me see that a second. Would you mind? Thanks. All right, I'm going to see what the slide length is. And on this one, it should be about 8. But come on. These are cruddy ones. That's why I have them here. I don't use these. I like the dial ones. Okay, it is .80. The 35, and I'm going to make it 8 because it'll be just a tiny under, and it saves me. So 8 is what I want to have this set at. So if I have this set, and the only other reason I use this is it's got a really, really fine depth adjustment where my dial calipers are like this wide. They're a really pain in the neck. So what I'm going to... What's that? I could, I guess.
Right?
All right. The beauty of this...
They only cost $10.
See, I already have this set. There's the stop, and that's where I want it to end. So I've got it set exactly where it needs to be. Put it back in here. It goes all the way through, so I've got lots of room to do this. On this female slide, now, same kind of thing. Female welt, the water seal in here. I try to make these fairly tight too, but not as tight because I want to be able to move them around a little bit. And the beauty of this is that I can, I'm doing it the right way. Oh, no, I'm not. You guys got ahead of me. I need to clean it. I didn't do it. I would have been really sad. You what? I get talking and I forget my words. What am I doing? Yeah. Okay, these are all actually pretty clean. A lot of times, you'll know it. If it's not soldering well, you'll stick a Q-tip down in there with alcohol and you pull it out and it look like something from the Black Lagoon. So that'll tell you didn't do it right. Okay, so I just have the welt is about that far in, but since this is set exactly to the depth I need, I can just slowly, if I'm good, now it's not going to go. I have this one quite tight, so what I'm going to do, I'm going to put it in here.
I got another question for you.
Sure, keep going. I've got to pound this down a little bit. I like them to be in there tight.
Put your welt on your ferrule after this?
Uh-huh.
On your female ferrule?
Yep, and I'll do that next.
Alright.
Okay, so, come out of there. Yep, there we go. Aluminum is nice because it doesn't scar. And it's almost sticky. I wouldn't call it that, but it feels sticky. It holds things really well. And what's that? Yeah, it's great. And I also taper my ferrule tabs, and so they go in and it helps hold it as well.
Is that little height gauge
too far.
aluminum as well? The thing you got in there?
Absolutely. And the thing that's beautiful about aluminum is it doesn't hold solder either. Solder doesn't stick to it, at least not well. Keep trying. Okay, I'm check the depth gauge. Sometimes it's better. These are beautiful. Okay, just got to come back just a little bit. I'll know how deep it has to be. On this one, I'm going to probably undo it. Larry, your question I answered wrong. Yes, I would normally solder that on first, but I'm just going to do this way now to show it, and because you would normally want that welt on there and turned because you want that depth. But this, I pretty much have it cut to where I want it. So that end is where it's going to be. Does that make sense? I'm talking to say. Normally, what Larry's asking, there's a welt or for your shoulder that goes on the outside. This is machined again, so I'm going to have that on top of there. This will get soldered on in a minute, and then it'll get machined down so it looks right. I have this machined to exactly where I need it, and I will just machine it down till it's dead even with the top. So normally I would do that first so that you have the correct placement. And I'm still needing to go a little far. I overdid this one, which happens. And I have this one nice and tight. I like them tight because then they don't fall around.
They don't raise up on you when you're...
Ever had that happen, Larry?
No. Not me. Have you ever?
Oh, thanks for your patience.
Wait, hold it.
This is the hardest.
Keep your rod to jam it back down.
This is the longest part. I want this to be right because you want your male ferrule to fit in exactly as far as it should be. And this one, it's a .80 throw. I'm getting close, so I like to be really careful. I want this to be as close as it'll be. On this one, I've only just started making this little jig. On this one, I think I should probably, just in the future, make these little plugs a little smaller, because then I can just set this and move it easier. But right now it's so tight that I'm not able to just go with it. Okay, I went the other way.
How close do you set that tolerance, Randy? In other words, your male slide's 800 thousandths.
I go about .2 off. I give it about a .2 play.
2 thousandths.
Yeah, it's hard to say. I mean, some people say, "Oh, yeah, it's enough to break it," but I'm not sure it is.
2 is that 2
2/10. Sorry, 2/10 at the very most. Let's see. So anyway, I get this set, and so I would normally, with this jig, if I made it a little smaller, which I wish I would have, all I would have had to do is set it down on top of here. And that will absolutely set it. It'll be exactly where you need it. Yeah, that's real good right now. It's going to get machined down. Okay, so that's setting right where it should be. Now, I'm going to solder this the same way I just did that, the end of the male ferrule. But the problem with this one is I don't want to solder from this side, because the first thing that happens is you get lead inside the female. You don't want that, because then your male slide's not going to work. So I'll do this one backwards. I'll set it back down in here. That's the way you want it to set. Just there we go. Now it worked. I want it to set just like that.
From the bamboo side?
What's that? Yes, drop solder in from the bamboo side. So I'm going to drop a drop of flux.
So that's your bamboo side there.
Yep, bamboo. These are the
Serrations,
serrations are up. That's one of the reasons I wanted to do that, so you could see that a little easier. Scissors and lead. That's another reason I like lead, because it's so malleable and easy to mess with. And you don't need very much. So you're just cutting basically a little tiny square. You're dropping it in there, and on this one, because it's a little tight, I want to make sure it's all the way down in there. I just want to tamp it down. It's good. What's that? No, thanks. Was that 3 times? I was trying to figure out how many times it would take. Okay. There it is. It won't move anywhere. There it is. I'm sure it went. It takes almost nothing, and it's held in place, and the aluminum doesn't stick to the steel will stick. And the reason I don't use wood or bamboo or anything else to hold it in there is because you're heating that hot, that wood burns. And what does wood do when you burn it? It puts off smoke and soot. And where does the smoke and soot go? Right into your joint. And what did we say first? Cleanliness. If you have smoke and soot and garbage inside there, then none of the solder wants to flow. Hey, Larry, do you have a light?
Sure do.
If that moisture
Nah,
cap is not good and tight, that's kind of a troublesome procedure, because the solder seeps down under the moisture cap and into the female.
Absolutely.
Yeah, well.
And that's hard to get out.
That's hard to get out.
Yeah.
And now it doesn't flow into the male. So you do it from the bamboo side, and then you don't get anything up inside. You just have a nice clean shoulder. I'll pass this around after I do this. I have one more step I want to do. There's lots of little different things, but as you go, you can solder a set of ferrules really pretty quickly. Just lots of little tricks you can use that make your life easier. Just constantly remember to be clean, and lots of flux. I'm going to say that over and over and over and over, so you'll get bored with me, I'm sure. But all right, now this one, 2 different size tubing, and again, this is ferrule. I make my ferrules out of tubing as long as I can get it. When that changes, well, I'll do something else. 2 different size tubings, and I like to put that shoulder up on there. I have machined it. I like these to be a little oversized, so when you machine that shoulder, this goes on exactly straight. If you had this exactly the same size, it's real easy to get something like this. Get it cocked on there and look at it and go, oh, good grief. So it's much better to be able to have it because it goes on perfectly straight. You're turning it on a lathe. It helps to have a lathe. And that did flow, didn't it? It just goes so quick. It is just it's a beautiful thing.
Well, I've had problems in the past where your disc will want to float up on you.
Absolutely.
You jam it back down.
Okay.
But I also use silver solder on all this. So.
Yeah, and I say silver solder to me heats so stinking hot, and it doesn't flow well. I like lead solder, and I have yet to ever have it fail, even on ferrule parts that you're really reefing on that thing, and it's not doing anything.
Back when I was in crafts class in high school and stuff,
That was a long time ago, though.
it wasn't.
Another. Oh, sorry.
You couldn't use like lead solder on, but that was sterling silver, correct, Jeff? Solder will not. No, it'll just eat it.
Yeah.
The problem with silver solder and silver solder flux, since we're talking about it now, like when I ran a shop in the Air Force for music instrument repair, I was a trombone player for the Air Force, and they would not allow us to have silver solder. It had to be cadmium free because cadmium is a cancer-causing agent. So, third thing I'm going to say, have ventilation. What's that?
And lead's not.
Lead is bad too. We fought for that. We got to have that because it was the only thing that worked. You've asked about lead-free solder. I have some, and it works. But the thing about it is, it takes almost as long to melt this as it does to melt the silver solder.
And you run into problems with warping and
Right.
all sorts of things.
And you're softening it. You're annealing. Nickel silver is basically brass. It's white brass. And if you heat it hot enough and you heat it red hot, it's going to be soft. That's why you do it on a trumpet. You heat that dent up. If it's a real dent, hard. You push it on a mandrel to get that dent out. It's so sharp you can't get it out. So you heat it red hot and let it cool, and it goes really soft. And you go beep, and it's out. So you think about that in conjunction with a ferrule. Do you want to heat that ferrule so hot that it goes like that? We had one of my favorite musical instrument repair stories. We had a kid bring in a trombone. His dad was evidently an auto body repairman, and you know about this. And you take oxyacetylene, is it, and you heat dents and put ice on them. That's what he thought, and the dents pop out. So he brings. No, this was at the music store I worked at. He brought in a trombone slide, and I touched it, and it crumbled. I said, what in the world happened? He said, well, he's a body repairman. He thought he could take that dent, heat it red hot, and put ice on it. Well, he hit it red hot, it crumbled. So I thought, yeah, you don't want this. Okay, I'm going to start on, and this is maybe a little trickier, and I really, really wish that torch was working. It's ticking me off.
Keep your body man away from your trunk.
I kind of don't. Is the tank on? I bet it's not going to. Yeah, it is now.
Whoa!
Here. Be careful not to burn yourself. I wish these little things worked better because they don't. The thing that I found, if you're using this, you have to get it just barely on. The wind is blowing. Well, it's working out. When you're trying to solder this is where it gets a little bit touchy, and that's one of the places that like pounding your solder, this makes it a whole lot easier. You've got this little tiny, and I don't know if I can show you. I'm trying to solder the shoulder on it, and I'm going to have to go from the inside. I can go from the outside a little bit, and maybe I will on this one a little bit. Would you hold this? Would you hold that a second? I don't want to turn it off now that it's working. I didn't want to do it, but I am going to do this from the outside this time. Anytime you can try not to get solder inside your ferrules, especially where they're going to join, that's a good thing. Thank you. So I'm just going to do this almost like I did that first thing I did, the plug in the bottom of a real seat cap. Give it just a little bit. Oh, this is so much easier now. You need more flux and you can really direct it. That's why I like these. Get a glass eyedropper. Don't get a plastic one. Acid eats them away. Don't ask me how I know. Yeah, it does. So a glass eyedropper works really, really well. Give it a little heat. Paint it around. Heat it evenly. There it went. That's all it needed. And you can actually see it went all the way around. So the thing is, if you get it clean and fluxed properly, you touch it, you get it, and you heat it all around. Heat it evenly. Keep it moving. Don't heat it in one spot, or the solder won't flow. So get it very, 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 very hot. And then touch one time with that little flattened solder, and you'll just see it go, and it just follows that flux. It's wonderful. I did. I'm doing it again. No, that wind blew that lighter right into my thumb. It hurt. All right. I got a couple more. All right. I have one more thing after this I can show you, and then I'm going to go on a little bit to silver solder. So after this, this ferrule is ready now to put on my lathe, turn it down, and polish it. That little bench motor is wonderful for polishing, too. You chuck them up, and you can use light steel wool, and also you can put a buffing wheel in it. if they're easy to make. I mean, I bought mine a long time ago, but having that foot switch, it's really fast compared even to a lathe. It's easy to set. It chucks them up. You got to be careful. And then you can use light sandpaper on them as it spins. You can use steel wool, and then you can take it and you can buff them. So think about doing. If anybody wants to figure out more about it, or talk to me more about it. A bench motor. That is basically a finished female ready to go. Okay, the next other thing that I do, I have another butt cap, and you'll be able to see what it looks like once it's turned. I also, on my butt caps, that's pretty tight too, I like to have a knurled ring at the top. So one of the things I'll do on this, again, these are a little bit undersized compared to the OD of the butt cap, which I really like, because then you can cut a shoulder in there, and it makes sure that, again, it's straight and it pops right on. One of the things I do when I do that, as I pass around, you'll see this, make it at least, I don't know, I'll measure it just to be
32nd.
A 1/16 of an inch at the most, 32nd, yeah, Jeff. Probably at least about, probably 0.3, 3/10 over, because it gives you somewhere to touch your solder. All right, well, here's another thing that this thing does well. Now, I made a larger, drilled a hole in here that's the size of one of this. Man, this little thing has solved so many problems, because how do you set something like that up and be able to solder it? It moves all over, and like I said, security is really great for soldering. If not, it falls, everything goes to heck in a handbasket really quick. All right, so that sits in there really nicely. Again, I'm going to clean these out a little bit just to make sure I'm in good shape. Q-tips, painter's rags, denatured alcohol, scrapers. I think I have all that in there. Little tools that make it easier. You can do this with a minimum of tools, but it's nice to have a few things that make it easier. I'm also going to clean inside here. Now what this is bigger size tubing, 690 and 655. This is the size of tubing that I get from Allen. It works really well. I will knurl this on my lathe first and then cut it off. And that's how I'm doing that. I mean, for those of you who aren't, does everybody know what knurling is? I guess most of you do, I'm sure. I didn't mean to talk down. There's knurling on here, and I don't want to get lead in the knurling, if at all possible. So I don't want to solder this from the outside by any means, if I can possibly help it. So I am going to make sure I get some good fluxing inside there. In fact, I'm going to take that off again. I think I did it already, but I think it's drained off. Don't be afraid to overflux, but don't let it run all over the place either.
Why not? Why not knurl afterwards, Randy?
Because these are short and they're hard to reach with my knurling tool.
Okay.
And it also then, if they get jacked up, if it moves or catches, it goes bing. Don't ask me how I know.
You've done them.
I've done them both ways.
You've done those weird knurls that go all over the place. As well, yeah.
This I'm putting in. This had a burr on the top. Now it's not wanting to go. I'm gonna do it down here. Come on, don't be a pain. Why are you being a pain?
Because you're making a presentation.
There we go.
Of course.
Are you not gonna go on? No, it's not, is it? I bet I just jacked it up too.
Get a bigger hammer.
Hey, this was my first hammer when I was a kid. Give me a break. There it is. Stinker. Always the answer is a bigger hammer. Totally a bigger hammer. Okay, so this is hopefully going to hold a little better. Please work. Alright, so I'm going to heat it from the top, and this holds it nice and secure. I already have 1 drop of flux in there. Nope, I have 1 drop of flux inside there. I'm going to actually do one more. I think actually what I want to do, I'm actually going to tip it just a little bit, which is another thing that this does really well. Tipping it helps me to see it. Going up and down, you're trying to get in it. This gives you a nice way to touch that solder to that joint. I'm probably going to flux it again. I want to see it bubble a little bit. Okay, there it went. Just bubbled just a tiny. Now I'll do it again. And do not, if you can help it, on something like this, get any flux into that knurling if you can. You watch, I'll probably do it, but at least it'll be a good lesson of why not to do it. I want my glasses on so I can see where I'm going to put this. Alright, it's bubbling well, and I want some control. it went. That was all it took. It just did a nice little... Oh, I'm gonna have to get that out. Oh, are you okay? Sorry. You're in my splash zone. That's all right. Larry will buy you new ones. I got a little bit of lead in here. Would you pick that up for me?
No.
Really? I'll get that out later. I'll show you another easy way to do that. Yep, that flowed pretty well, and it did not get any in the knurling, which I'm really happy about. And by wiping it that one time, it came out pretty good. But there's one other thing that I really, really like a lot, scrapers. Tri-scrapers. Small tri-scrapers, and actually this works really good when you've got a little bit you need to clean out around a knurling. It's a hook scraper. These things are wonderful. Say if I get a little bit of lead out here and I don't want to wipe it, you just go around it like that and scrape it. Be real careful, you'll make a gouge. Works really well. So this one, I'm going to do it right now. I got a little bit of lead in there and I don't really like it, so I'm just going to take my scraper, get in there and just scrape it out. And it doesn't matter, it's inside, but I don't want it to not fit well on my real seed insert. Am I taking too much time? Oh, we're good. I'm almost at, anyway, we're almost at an hour. Gary, is that going to be?
Yeah.
Do I have just a couple more minutes, or you want me to wrap this up?
No,
Wrap it up?
I think you're good.
Okay. I'll show one quick here. Pass this around if you want to see it. That's the finished butt cap. All right, silver soldering, real quick. Silver soldering is hard to do, and like I said, the only thing I do are my little rings. And those are actually because they're under a little bit of pressure. This was someplace I could never quite figure out a good way to do it. So you can buy cheap hemostats. They're very cheap. I will take this little ring. I make these out of nickel silver wire. I wrap them around a mandrel, and then I saw through them. And so you end up with these little rings. I'll put them in a pair of hemostats, hook them up like this. This is where MAP gas really comes in good, because with silver solder, you need it to be almost red hot, at least for me. This is silver solder. It's harder to get. I've had this for years. You don't use hardly any of it, and it's very high temperature. The silver solder flux, mine has gone powdered. It basically turned to a rock. So I just pull out a piece, and with a mortar and pestle, I made it powder and rehydrated it with water.
About 15 years back, Randy, I got lucky and got a bunch of silver solder from Radio Shack.
Did you really?
It's about 8 times the diameter of a human hair.
Oh man, this is one place I use something kind of flammable. All right, so what I'm going to do, I am going to take just a little bit of this flux, and I am actually going to really goober it into that little hole. I actually want quite a bit. And I want to actually fill it. And I'm going to heat it until that flux melts. You almost see it in there. Where'd that toothpick go? Okay. I can't see it because I have good glasses. There we go. I got it. Now, yeah, Larry, do you have a light? Okay, I am going to heat that thing until it is red hot. Or as much red hot as I can get. And there it went. There it went. I probably would put more on here, but maybe not. There it is. Yeah, it's not a good one. There it is. That's all it takes, and that's the only reason I use MAP gas. It's just, oh, that's not true. I flame with MAP gas on my combs because it goes really quick, and you can control the color, and it goes black really quick. And by doing it that quick, I know you don't agree with this, by doing it that quick, it actually is cooler because you take it and the inside's not cool. So I actually do it because I like the quickness, and I flame my combs until it bubbles. I don't let it bubble. I just go down it as it turns black because then it comes very even, and as soon as you polish it off, it's amber. So that's about all I had here. That's how you silver solder. You can come up and take a look at this if you want. Does anybody have any questions right now? No, that cooled fast. That's one good use for really cruddy hemostats. Oh, and getting tape off of you, it's full of glue. So, any questions, anybody? Good. Well, thank you very much.
So how does solder is really blue, or can you get it off?
No, it will not.
It doesn't blue well. It will a little, but not much. It's spots.
Even with
Silver will.
deep silver solder.
Well, blue.
You have to use, yeah, I barely.
Well,
It's
I'll
not
show you.
It's not liver of sulfur, it's the other one.
Actually,